This do now is asking, what is the relationship between triangle RTP and triangle STQ? Pause your do now so you can complete it. You should know from last week that these angles intercept the same arc, so they're congruent, and these angles intercept the same arc, so they're congruent, which means that these triangles are similar to each other by angle. Alright, today and tomorrow we'll be looking at the relationship between two chords in a circle. We'll also tell you what a chord is officially. And then Wednesday and Thursday is the Unit 9 project, and next week is the last chance you have to make up any work. It is all due on Friday. I'll also be handing out a survey on Friday, which you should complete for credit. So today we're going to be looking at the relationship made by two chords. And first off, we should define what a chord is. Not a guitar chord, but a chord is when you have a line segment whose endpoints are on the circumference of the circle. So actually right now we have a lot of chords here. We have, let's highlight them here. We have 1, 2, 3, and 4. But specifically the relationship I want to look at is if you have any circle and you just have two intersecting chords, there's relationships between these little pieces. And these are just here to help us along. Now, in the do now, we showed that these two triangles are similar to each other by angle. And we could label the angles that correspond to each other if we want to. That corresponds with that. That corresponds with that. And the vertical angles correspond as well. So what I want to look at now is I want to think about the relationships with the sides. So like side RS. That corresponds to side ST. And remember, if we do this in similar triangles, we have RS over ST, these ratios should be equal to, say, PT over TQ. Now, one way, this is always true in all of these things. You can always write this with the two chords. This is a good enough relationship. This will get you places. You know that this part over that part equals this part over that part. Same thing. But it looks a little easier when you cross multiply it. Then you can think of it this way. So if you cross multiply, we end up with RS times TQ equals ST times PT. Now these look a little weird with the letters and everything, but think of it this way. If we label this little side A, and this B, and this C, and this D, those are our side lengths right there. The two parts of the same chord, so these are both on the same chord, and then these are on the same chord. The two little parts, if you multiply them, they equal each other. So like part 1 of that chord times part 2 of that chord equals part 1 of the other chord times part 2 of the other chord. And this all works because we can form similar triangles. So if we take a look at this first example on the left, I already labeled all the diagram with the numbers you have. And now we just think of our rule. So like, we have a part of one chord times a part of the same chord equals the part of the second chord times the other part of the second chord. So if we look at, say, AB, for example, that's one of the chords. The two parts of this are 5 and 16. And now, if we look at CF as the other chord, the two parts there are 10, and EF, what we're trying to find, is X. So now we have a very, very easy equation to solve. 5 times 16 is 80. 10 times x is 10x. We divide by 10 on both sides. And we know that EF is 8, which is what we're looking for. Now in the second question, they give you that AE is 2. They give you that CD, this entire length, is 9, and that CE is 4. And we're going to look for BE. So the rule again is we're going to have part times part equals part times part. Now the thing here, they give you the whole length. So in order to find this little piece here, we want to subtract. And we do 9 for the whole distance minus 4 that we already have right there. That makes this thing 5. And now just to simplify matters, I'm going to get rid of this 9 because it's a little bit in the way. So here, the first chord we have, and you can do it in any order, it doesn't matter. We have 2 times x, which equals, on the second chord, 4 times 5. So 2 times x is 2x. 4 times 5 is 20. Divide by 2. X equals 10. And we're looking for BE, which is x. So our answer is 10. So just remember the relationship when you have two intersecting chords is each part, if you multiply them and set them equal to each other, you can solve from there. So like part 1 of a chord times part 2 of the same chord equals part 1 of the other chord times part 2 of that other chord. And after you finish your work, your wrap-up question asks you to explain how similar triangles can lead to this relationship between intersecting chords.